right, so in this video, I'm going to review percent composition, and there are two ways that you can determine the percent composition for a molecule. The first is if you're simply given the mass of each of the elements. All right. The second is if you're just given the formula of that compound, in which case we would use the molar masses rather than just the masses. So let's look at a couple of examples here. So the first question, it says a chemist determines that 1.26 grams of iron reacts with 0.54 grams of oxygen to form rust. What is the percent composition of oxygen? So in order to determine percent composition, you need to take the mass of what you are interested in, and you're going to divide it by the total mass of the compound. So in this case, I'm interested in oxygen, so its mass is 0.54 grams. Okay, and then we're going to divide that by the total mass of the compound. So I need to take the mass of iron, which is 1.26, and you need to add to that 0.54. And for that, I get 1.8 grams. All right, so I'm going to take 0.54, divide by 1.8, and then multiply by 100 to make it a percent, and that will give me my percent composition. So the answer that I get is 30. Now note, 0.54 has 2 Sig Figs, okay, 1.8 here, and actually, if I'm being perfectly correct, this should actually be 1.80, because when I add, I round based on decimal places, so I need 2 decimal places. But it doesn't really affect me because ultimately my answer is going to have 2 Sig Figs. So 30% would have to become 30% in order to get 2 Sig Figs. All right. So that is my percent composition of oxygen. The cool thing is I now know the percent composition that is iron, because remember the two elements have to add up to 100%. So if this is 30%, then I know that iron is 70%. All right, for number 2, it says in the lab, a chemist analyzed a sample of methanol and found that it was 6.2 grams of carbon, 4.1 grams of hydrogen, and 15.9 grams of oxygen. What is the percent composition of hydrogen? So I'm going to take the mass of hydrogen, what I'm concerned about, 4.1 grams, and I'm going to divide that by the total mass. The total mass is going to be the mass of carbon, 6.2, plus the mass of hydrogen, 4.1, plus the mass of oxygen, which is 15.9, and I get 26.2 grams to put on bottom. And now I'm going to multiply by 100%, right? And so when I solve this, I'm going to take 4.1, I'm going to divide by my 26.2, multiply that by 100%, and I get 15.65. I'm going to figure out my Sig Figs really quickly. If you notice, when you added 1 decimal place, 1 decimal place, 1 decimal place, that's why this was 26.2. 4.1, now that I'm dividing, it's based on Sig Figs. So 4.1 has 2 Sig Figs, 26.2 has 3 Sig Figs, so my final answer needs to have 2 Sig Figs. So I'm going to round this up, and this will become 16%, and that will be my answer. All right. Okay. So what if instead I don't give you the masses nicely like I just did? What if instead I just give you a formula, or not even a formula, just a name, because I can do that. So here I just tell you you have sodium phosphate, and I want to know the percent of each element in sodium phosphate. So the first thing that I need to do is I need to write the formula for sodium phosphate. Well, I know that sodium has a +1 charge, right? I know that phosphate has a 3- charge. So I am going to cross my charges here. And what I end up getting for my formula is the following. I have Na3PO4. All right, so to determine the percent composition of each element in this compound now, I need to take the mass, the molar mass of each element, the total molar mass that it contributes to this entire compound, and divide it by the total mass of the compound. So to begin with, sodium, I have 3 sodiums, so I'm going to take 3 and multiply by 22.99, which is the molar mass of sodium. That is 68.97. So 68.97. I am now going to divide that by the total molar mass of the compounds. Well, I've got to take that 68.97, and I'm going to add to that the molar mass of phosphorus, which is 30.97, and then I'm going to add to that the molar mass of oxygen, which is 16 times 4, and I get 163.94. All right, so that is the total molar mass of the compound. I'm going to take this, I'm going to divide, and then I'm going to multiply by 100%, and that will give me my percent composition that is just sodium. So I'm going to take 68.97, divide by the molar mass, 163.94, and I get 0.4207. I need to multiply that by 100, and I get 42.07 keep in mind, I'm trying to figure this out quickly on the fly. I think it honestly, these answers, guys, depends on the molar masses that you're using. So I was lazy and I grabbed a different periodic table than what you guys have. So honestly, in all likelihood, what I will tell you is, hey, please round your percent composition to this number of decimal places or this number of Sig Figs. So I got 42.07 based on the Sig Figs that I have. From my molar masses, it should be 42.07 instead of 42.1, which I got here. Either one is honestly fine. I would stipulate on a quiz or test or any sort of assessment to what percent you should be rounding your answer. All right, so 42.07% is fine. That is for sodium. All right, now I'm going to do that for phosphorus and for oxygen as well. So for phosphorus, I know that the molar mass of phosphorus, I only have one of them. Its molar mass is 30.97, so I'm going to put the 30.97 on top, and I'm going to divide by the total molar mass of the compound, which, as we previously noted, was 163.94, and I'm going to multiply this by 100%. Okay, so when I do that, I'm going to take 30.97 and divide by my 163, and then I'm going to multiply by 100%, and I get 18.89, okay? I'm going to round that to 18.89. I got in the answer here for the actual book, 18.9. Either one is fine. Again, I would stipulate what I wanted you to round to. And then finally for oxygen, keep in mind it might be tempting to put 16 on top. However, I have 4 oxygen. So I'm going to take the total molar mass, 16 times 4, and divide that by the molar mass of the entire compound, which is 163.94. And then I'm going to multiply this by 100%. And what I end up getting here is 39.04, or 39.0 is fine as well based on your rounding. All of these will add up to very close to 100%. It might not be perfectly 100% simply because of rounding error. Okay, so that's how you determine percent composition given just the formula and not the masses. You use the molar masses. Okay, let's look at one last problem. Here I give you the formula and I want to know the percent composition of each element in aspirin. So if we look at carbon to begin with, okay, I need to take the molar mass of carbon, which is 12.01, and I need to multiply that by 9 because I have 9 carbons. So it's going to be 108.09, which is the total molar mass of carbon. And now I need to divide by the total mass of aspirin. So I'm going to take that mass of carbon and I'm going to add to that 8 times my molar mass of hydrogen, which is 1.008. And then I'm going to add to that the molar mass of oxygen, 16 times 4. So the total molar mass of aspirin is 180.154 grams per mole, if you didn't know that. Fun fact. All right, so that's the total molar mass. I'm going to divide and I'm going to multiply it by 100. And what I end up getting here is 59.998. All right. If you want to round to 4 Sig Figs, that's fine. 5 Sig Figs. I'm going to just keep with the answer that I put here. So 59.999. I'm going to show this right above here because this is a little bit tricky of rounding. 0.998. Remember, if you want 3 Sig Figs, the 8's going to round the 9 to a 10. This 9's going to cause that to round up, which is going to cause that to round up, and you end up getting a lovely 60.0% for your percent composition. All right, so that's for carbon. Let's now do it for hydrogen. So for hydrogen here, I need to take the total molar mass that hydrogen contributes, which for aspirin is going to be 8 times 1.008, which is about 8, but I'm going to just be exact here. So it's going to be 8.064, and I'm going to divide by the total molar mass. All right, and then again, I'm going to multiply by 100%. Okay, and so the percent composition that you get for hydrogen here is 4.476. If you want to round to, for some reason rounded to 2 Sig Figs. I think I was asking you just to round to 1 decimal place, which is probably why I rounded that way. It shouldn't round then to 4.4. It should round to 4.5 if I'm rounding properly. So I'm going to round this properly. I'm going to put it at 4.5%. This is all just a rounding game, all right? So there's going to be some rounding error there. And then for oxygen, all right, I have 4 oxygens here, so it's going to be 4 times 16, which is exactly 64, divided by the total molar mass of aspirin, which again is 180.154, multiply by 100%, and I get 35.525. So I'm going to just round this to 35.5. All right. So there might have been a rounding issue in my answers. I might have used a different molar mass. That's perfectly fine. Either of these answers is perfectly fine.